Alright, so we're doing exercise 10D, and in this video I'll be answering 3C. So let's read the whole question. So 3 letters are chosen at random from the word heart and arranged in a row. Find the probability that both vowels are chosen. Okay, so there's a lot of information there. So things you need to take consideration of is the fact that we're finding the probability and that we need to find if both vowels are chosen. The word chosen here is very important as well. What does the word chosen here tell us? It tells me that the order doesn't matter. We simply need to find 3-letter words that have both the vowels in it. It doesn't tell us where those vowels have to be. They don't have to be in the first or second or third position. We have no mention of that, which means the order doesn't matter. Does not matter. So that's the first thing you need to figure out. Does the order matter or not? And the fact that it doesn't matter tells me that we're dealing with a combination question. We're dealing with a combination question. Now, to find the probability that both vowels are chosen, it's simply going to be equal to restricted over unrestricted. So in other words, all the different combinations which involve both the vowels divided by an unrestricted combination. So that is simply all the different combinations of 3-letter words which are chosen from these letters. I get confused between saying letters and words. Oh, life is hard. Okay, so let's go. So let's first begin by finding how many different combinations of 3-letter words have both vowels in them. Okay, so to do that, what we're going to do is realize that, all right, we're dealing with the word heart, H-E-A-R-T. And if I need to make sure that both vowels are chosen, that means my word has to have E and A in it. So that means I have E and A, both of these have to fill 2 positions. So N equals 2, R equals 2, and the reason for that is because I need to make sure that both of these letters are in here. I then am going to multiply that by my third space, because I've already taken up 2 spaces here. I have 1 more space to fill. Well, how many different options do I have for it? I have 1, 2, 3, the H, R, and the T, 3, and I have 1 position to fill. So let's really break this down for a second and figure out what this is going to be. So what is 2C2? Well, this simply means I have E and A, and they need to fill both positions. Well, I can immediately tell you what this is going to equal. It's going to equal 1. Because, remember, my order doesn't matter, so it's simply going to be E and A. Too easy. And remember, A and E doesn't count as a second option, because the order doesn't matter here. It's just E and A. Too easy. Now, the next bit is going to be multiply that by, what is 3C1 going to be? Well, I have H, R, and T, and from these letters, I need to fill 1 position. Well, that's going to be 3, because remember, I could have H, or I could have R, or I could have T. So they are my 3 options. Oh, these brackets are looking horrible. So it's just going to be 1 times 3, which is going to be equal to 3. Now, you don't have to do this working out. I just wanted to show you what's going on there, how we're going to find out that there are 3 different combinations of 3-letter words that are going to have both vowels. A way you can do this is simply pull out your CAS and go, let me just clear everything here. You can go here, you can go menu, you can go probability, you can go combinations, you can go 2 times. Now you can also go NCR. That's quicker, I think. 3, 1. And my answer will be 3. Too easy. There it is, 3. So let me grab my blue highlighter. That represents my restricted one. So that is the same thing right there. And that's what I times together. So I could let me put a multiplication sign there as well, so we know what's going on. So this is going to be 3 here. Grab my highlighter, highlight that. I now need to find what my unrestricted is going to be, which isn't going to be nearly as hard. I have 5 letters I'm choosing from. They have to fill 3 positions, and I know that is going to be equal to 10. You can check this on your CAS if you want. CAS NCR 5 and 3 is equal to 10. Huzzah. So I put 10 here, and that's going to equal to 0.3. Let me do some highlighting. So that is my green one, that is my green one, that is my final answer, 0.3. And that's your answer, nice and easy. Now, it's fine if you want to stop here, but I also want to show you another way of doing this. So let's call this option 1, there is another way to approach this problem. Let's now look at option 2. Option 2. So this is so you can just get a full view of what's going on. You don't have to do it this way, but I still think it would be good for you to see how it is that we could approach it a different way. So what we're realizing is that if we want to find the probability that both vowels are chosen, that's simply going to be equal to 1 minus the probability that both vowels are not chosen. So what we're going to do is we're going to find the probability that both vowels are not chosen. So that's going to be the restricted over unrestricted. So let's find the restricted. Well, for both vowels not to be chosen, what combinations are we looking at there? Well, I could have a combo that has no vowels in it. And I could also have a combination with one vowel in it. One vowel. So remember, I'm dealing with the word heart. Heart. So if I was doing no vowels, that means E and A are out of the picture. So I have 1, 2, 3 words to choose from. Yeah, no, it's 3 letters to choose from. Bleh, words and letters. I have 3 letters to choose from. I have 1, 2, 3 letters to choose from. I'm sorry if I've been saying words. I have 3 letters to choose from, and I'm trying to fill 3 positions. Now that's going to be equal to 1, because remember the order doesn't matter. So H, R, and T, I've got 3 letters trying to fill 3 positions. It's simply going to be equal to 1. You can check with your CAS, or you can just believe me. Now, second. How many different combinations are just going to involve one vowel? Well, what that means is, let me come over here, let me get rid of these. I can either have an E or an A, but I can't have both. So that means I have 2 options, but I only have 1 position for them. So it can either be an E or it can either be an A. It can't be both. So previously it was 2, 2, because I had 2 vowels and they're filling 2 positions. But if it's 1 vowel, it's going to be 2 vowels, but it can only fill 3 positions. And that means I have 1, 2, 3 consonants I can choose from. And they're going to fill 2 positions. So I've created my 3-letter word. 1 plus 2 is 3. And hopefully that makes sense how this is 1 vowel. So now I could pull out my CAS and I could solve this out. So it's going to be NCR 2, 1 multiplied by NCR 3, 2, which is going to be equal to 6. Then, to find the total restricted, what it's going to be is these 2 plus each other. So it's going to be 1 plus 6 equals 7. So that right there is going to be all the different combinations which are not going to have both the vowels in it. So here is one vowel and here are no vowels. So it's going to be 7 over 10. Remember, I got that 10 from over there. I don't need to do that working out again. So that is going to be the probability that both vowels are not chosen. I then am going to have to come up here and say, all right, my answer is going to be 1 minus 7 over 10, which is going to be equal to 3 over 10, which is equal to 0.3. I then get my highlighter and I highlight that. Now, as you can see, the second way of doing this is far more time intensive. I think the first way is far easier, far nicer, but it's important that you realize both ways of doing this. And someone asked me this question, so I thought I might as well answer it for all of you so you can all see how it is I approached it. Hopefully this helped, and see ya.